folks, it's Meg, as you know, from your Orgo 3 class, and I am here to tell you about the Hofmann rearrangement reaction. So let's just look at a quick overview. So we start with a primary amide, and we end up with a primary amine, as we see here, as well as carbon dioxide as a byproduct. So what conditions does this happen in? First, you have to have a halogen, so either Br2 or a Cl2, a strong base, in this case NaOH, and it must be an aqueous solution, and you'll see why later in the mechanism, and then, if need be, a little bit of heat to kick that reaction off. Alright folks, let's take a quick look at the mechanism. We're going to do two deprotonations, and then an intermolecular proton shuffle, and then we are going to lose a carbon dioxide to give us our product. Let's go through it. First, we're going to do a deprotonation to form this intermediate. This allows a lone pair of electrons to swing down, form a carbonyl, and a halogen, in this case bromine, to be added to the nitrogen. So this is called an N-alloamide, which is our next intermediate where we do a second deprotonation. This allows us to form this lovely intermediate here, which has resonance. So let's do that. That resonance form leaves us with a negative charge on the nitrogen. And what do we have here, because we added it? A great leaving group. Let's make it leave. That allows us to form nitrene. A nitrene intermediate has an empty orbital where there are no electrons, which it wants to be filled. So let's do that. It's called a rearrangement. This is where the Hofmann rearrangement comes in. And that allows us to form an isocyanate intermediate. So now we have two double bonds on a carbon, one's a nitrogen, one's an oxygen. Water can now add, and this is why we need to be an aqueous solution. That leaves us with this thing called a Zwittier ion, which is a ion where there's both a negative charge on oxygen and a positive charge on the oxygen. So first thing we can do is we can deprotonate to get rid of that positive charge. And we are left with this intermediate. What can happen now is we can form the next intermediate by taking a hydrogen and moving it over here. Now what needs to happen is an intramolecular proton shuffle. It can happen intramolecularly, however that's unlikely, so I'm going to show you the intermolecular form today. How does this happen? We take a hydrogen from the carboxylic acid group of the same molecule itself, which leaves us with this intermediate for this molecule that we just took hydrogen from, and this intermediate where we just added the hydrogen right here. So now we have to do this again, so all of the molecules end up in this state, which would allow us to lose that carbon dioxide. So how do we do that? We have a nitrogen right here that has two lone pairs and can take the hydrogen from another carboxylic acid group, and leaving us with all of this intermediate. What can happen now is we can get rid of some carbon dioxide because it's entropically favored, because forming a gas is always something that increases entropy. So how do we do that? As we saw the other day in class, we form the double bond, and the amine can leave, the primary amine. So that's where this amine forms. And then we have the carbon dioxide that had just left, and we have now finished our Hofmann rearrangement reaction. So let's take a quick look at our literature piece and figure out where the Hofmann rearrangement can come into play. So we have this article, the enantioselective total synthesis of plus dibromofalcalstatin. So this product right here is dibromofalcalstatin, and this is the very last step of the synthesis. So to get from these two functional groups to making one ring, we have to go through a Hofmann rearrangement. How does that happen? First, we start the Hofmann rearrangement by looking at this primary amide. So it goes to part of the Hofmann rearrangement, to the part of the mechanism where we talk about the isocyanate intermediate, if you remember what that is. If not, go back to my mechanism. So instead of the mechanism continuing once you get to the isocyanate, for the regular Hofmann rearrangement general reaction that I showed you, we have a pendant amine reaction where this amine that already exists and is already somehow linked to this isocyanate through right here, these two react to form a new ring. So it's part of the Hofmann rearrangement. It's not totally it, but it does really help us form this new ring and get our desired product. So that is the Hofmann rearrangement, and if you have any questions, you know where to find me in person.